Alright guys, so for today we're going to look at what we call complementary probabilities. Now we did start talking about this the other day, but we're just going to go through it in a bit more detail. Should be pretty quick and easy, and then there's something else you need to do after that. Okay, so a couple of things that you have to know before we can look at do this. So this is a prior knowledge check. So the first one is, and again we mentioned all of these the other day, so the maximum probability you can have for any single outcome is 1, which means that there's 100% that is going to occur. You can also have multiple probabilities. Say for example we're looking at tossing a coin. So for tossing a coin there is 6 different outcomes, so 6 different things that can happen. That's a 4 by the way there, 4, 5, 6, okay, and each of these outcomes has a 1 out of 6 probability of occurring. Each of these things, because there's 6 things all together and there's 1 of each outcome. Now if we added all these together, or actually we'll multiply it, so because there's 6 of these and each of the probabilities is 1/6, 6 times 1/6, that's 6 over 6, sorry 6 over 1 times by 1 over 6, which is 6 over 6, which is 1. Okay, so the maximum probability that any one outcome can have is 100, but in each event, an event is anything that you can assign a probability to, any kind of thing that occurs that you can assign probabilities to. All of the outcomes in an event, those probabilities need to add up to 1. Alright, so hopefully that makes sense. I'm just going to delete this here. Okay, you don't need to write down that stuff because you should have it from Tuesday, but if you would like to, feel free. Okay, now moving on. The next little, what we're going to look at today is the idea of a complementary probability. Now the complementary probability is the opposite. Oh, and I meant to write this in here. Actually, I'll quickly write it in here. The definition. Okay, so I've just wrote it in there, and it'll be in your notes. So a complementary event is the probability of, or complementary probability, even better I should say, is the probability of not obtaining a particular event. Now I think the easiest way to think about this is as a Venn diagram. So if you, for example, make up a Venn diagram, we're going to look at people who have dogs or cats at home. Okay, so in this circle we're going to have dogs. We're going to say there's 15 people with dogs. Cats, we'll say 12, and 8 people have both. Okay, now the probability altogether, this adds up to 35. Okay, so the probability that someone has a dog would be 15 plus 8, which is, what is 15 plus 8, which is 23 out of 35. Now the probability that someone does not have a dog, okay, now for this bit, we're looking at everything not in that dog circle, so everything left over, which is just the cats, okay, which is 12 out of 35. So asking for the opposite probability is finding what's left over inside that Venn diagram. And if you want, you can draw a Venn diagram as you're doing this, and that might help a little bit. Okay, so the probability, and now we can get to that 12 out of 35. If we didn't actually have that Venn diagram written, we could work that out by doing minusing the probabilities instead, because we know both of these, that all has to add up to 1 because it's 100%. Okay, there's no one who has another option. Okay, so we could also work this out by saying the probability of not dogs is 1 minus the probability that they do have a dog. Okay, which is now 1. We want a fraction over 35. So 1 is a fraction over 35. It's 35 out of 35 minus 23 out of 35. Now 35 minus 23 is 12 out of 35. So you can see there that we still get the same outcome overall. Okay, which is what we're after. Alright, so we're going to go through and we're going to do these couple of questions here. Alrighty. So, question 1. You roll 2 die. What is the probability that 1 will not appear on the die? Okay, so this is actually quite a tricky question because this involves rolling 2 dice as opposed to rolling just 1. So there's lots of different things that can happen, and the easiest thing that you can do to show this is to draw what we call a sample space diagram, and this is actually what our next lesson is going to be. So we're getting a bit of a head start here. So to draw a sample space diagram, we use this when we have two events that we're looking at and we want to combine all of our things together. So we're going to draw up a table, and for our first dice, and that's really, sample space diagrams are just fancy words for tables. Then it's not really anything different, so don't get freaked out about it just because it's got a funny name. Really, it just means a table. So here we've got one dice. Now there's the numbers you can get for one dice down one side, and in a row on the top, that's your second dice. Okay, and we just draw up our table. Now I'm just going to change the colour of my pen, make it a bit easier to see. So for this first option, we can have a 1 and a 1. Then we can have a 1 and a 2, then we can have a 1 and a 3, 1 and a 4, a 1 and a 5, and a 1 and a 6. So there's all our 1 rolls. We can then also have a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, and a 6 and a 1. Down here we can have a 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. We're going to do the rest of the 2s. So that's 3 and a 2, 4 and a 2, 5 and a 2, 6 and a 2. Alright, now for 3s, we're going to have 3, 3, 3, 4, 3, 5, 3, 6. This is a 4, 3, 4, 4, 4, 5. 4, 4, 4, 5, 4, 6, 4, 5, 4, 6. Oh, that should be a 5, 4. Anyway, it doesn't really matter. 5, 5, 5, 6, 5, 6, and then 6, 6 there. Okay, so here's all the things that can happen when we roll a dice. Now, I'm going to work this out. So we're going to look at all of the probabilities. What is probably that a 1 will not appear? So with this, because there's so many different outcomes that you can have, it's easier to look at the probabilities where 1 does occur and then minus that from the number of times that 1 doesn't occur. So I'm going to highlight here every time I see a 1. So here's all the times we get a 1. Now work this out. Here we got 6 across the top there, and then another 4, so that's 10 altogether. So my probability of a 1 occurring is 10 out of, now altogether you've got 6 by 6, so 36 outcomes. Okay, you can count them if you don't believe me. Now, to work out the probability that a 1 does not occur, we're going to do the probability 1 not 1 is 1 minus the probability that the 1 does occur, which is 10 out of 36. Now again, I'm going to make that whole number 1 as a fraction, so that's going to be 36 out of 36 minus 10 out of 36. So 36 minus 10 is 26 out of 36, and then we can simplify that fraction. So divide it by spread 2, so that's 13 out of 36 divided by 2 is 18. Okay, 13 out of 18, and that's my final answer. Alrighty, just give me a second. Okay, so we're going to look at question 3 now. So Tinny and Minnie are playing a game of tennis. The probability of Tinny winning the game is 0.75. So write that down. So probability of Tinny winning is 0.75. What is the probability of Minnie winning? So now we're looking at the opposite probability. Okay, so the probability of Minnie is the same as the probability that Tinny does not win, because either Minnie wins or Tinny wins. And so that's 1 minus 0.75. Now, 1 minus 0.75 is 0.25, and you can do that on your calculators if you need. Just remember, your exam coming up is a calculator exam, obviously, because you're doing it at home, so feel free at the moment to now use your calculator as much as you like, within reason. Okay, question 4, and then I might get you guys to try 5 and 6. And I'll send you the answers to them in a bit. Okay, so question 4. A man chooses an item at random from 12 shirts and 18 ties. what is the probability that the man chooses is not a shirt? So, so first thing we should kind of think about is 12 plus 18 means you've got 30 bits of clothing altogether. So the probability that he chooses a shirt is 12 out of 30. Now the probability that he chooses not a shirt is 1 minus 12 out of 30. So that's 30 out of 30 minus 12 out of 30. Okay, which is 12 minus 30 minus 12 is 18 out of 30, and then we can divide both of those by 6. So 6 goes into 18 3 times, 6 goes into 35 times. So 3 out of 5 is your final answer. Okay, what I would like you guys to have a go at is 5 and 6, and then once you've done that, what I'll do is I'll email the answer around to you, so you should in a few minutes get the answer in your inbox, and then once you've done that, go on to My Maths and do the next activity. Alrighty, cool, catch you later.